How mathematics powers machine learning. Machine learning is often seen as practical and technical field focused on building models and writing code, but behind every successful machine learning model is a solid foundation of mathematics. Mathematics provides the language, tools, and methods that make machine learning possible. In this section, we will explore how key mathematical concepts connect directly to machine learning algorithms and why understanding them is so important for anyone working with artificial intelligence. Mathematics as the language of machine learning. Machine learning models aim to discover patterns in data and make predictions or decisions. To do this effectively, they rely on mathematical concepts to represent data in numerical form, measure relationship between variables, optimize parameters for best performance, evaluate how well a model is working. Without mathematics, machine learning algorithms would be impossible to build, train, or interpret. Linear algebra in machine learning and how it is used, representing data as vectors and matrices, performing transformations and operations on data, handling large data sets efficiently. Examples: images are stored as matrices on pixel values. Neural networks perform matrix multiplications to combine data and weights. Dimensionally reduction techniques like principal component analysis (PCA) use linear algebra to simplify complex datasets while preserving important information. Linear algebra makes it possible to handle and manipulate data in high dimensional spaces, which is common in modern AI. Probability and statistics in machine learning. How it is used: modeling uncertainty in predictions, estimating likelihood of events, making decisions based on incomplete data, assessing the reliability of results. Examples: classification models predict probabilities for different categories. Naive Bayes classifiers rely entirely on probability calculations. Evaluating model performance often involves statistical metrics like accuracy, precision, recall, and confidence intervals. Probability and statistics provide the framework for reasoning about the data and building models that make sound decisions even under uncertainty. Calculus in machine learning. Let's see how it's used. Finding optimal parameters by minimizing or maximizing functions. Understanding how changes in inputs affect outputs. Training neural networks through algorithms like gradient descent. Examples: gradient descent uses derivatives to adjust model parameters in the direction that reduces error. Backpropagation in neural networks applies calculus to distribute error information backward through layers for efficient learning. Calculus enables machine learning algorithms to learn by systematically improving their predictions over time. Optimization in machine learning. Optimization is a mathematical process used to find the best solution among many possible options. In machine learning, this usually means finding the values for model parameters that minimize a loss function, which measures how far predictions are from actual results. Examples: training a linear regression model involves finding the slope and intercept that minimize prediction errors. Neural networks adjust millions of parameters to minimize the loss across the all training examples. Optimization methods rely on mathematics to search for the most effective solutions without testing every possible combinations. Geometry and high dimensional spaces. Machine learning often deals with the data in many dimensions. For example, a data set with 100 features lives in a 100 dimensional space. Understanding the geometry of these spaces helps explain how algorithms like support vector machines, separate data into different categories, or how clustering algorithm group similar data points together. Practical relevance. Understanding how mathematics powers machine learning has several important benefits. It helps you choose the right algorithms for your data and problem. It allows you to diagnose issues when models are not performing well. It enables you to understand why certain techniques work and how to improve them. It builds your confidence to read research papers, documentation, and advanced materials in the field. Even if you don't perform every calculation by hand, knowing the mathematical principles behind machine learning helps you become a better practitioner and make more informed decisions. Throughout this course, we will connect these mathematical ideas directly to real machine learning algorithms and practical coding exercises.